So what is it?
3.
Trinomial. Very good.
Oh, okay.
Is it in descending order?
Yes.
Greatest common factor?
3.
It's 3, 6, and 3. 3, 6, and 3. 3.
So it doesn't have to be the same numbers for it to be the greatest common factor?
It has to be a factor that goes into all of them that I can pull out.
Okay.
Yes. So what is left in parentheses?
Y squared minus 2y.
Good. My next question in the strategy is what? I'm asking myself now what? Is there a perfect square for, in other words, if I can use a special product. Is this a perfect square? Is this a perfect square? So what do you expect or hope for? Good. What will be the middle term of this expansion? Forget about that. I'm here. This is my claim. So I have to make sure that the middle term from here is the middle term from here. What will be the middle term here? 2 times y with minus in front, right? Negative 2y. If this is not negative 2y, this is not the factored form of this. Is there a negative 2y in there? Okay, so then this is okay. And it's the only way. Okay. 16. A squared minus 24a plus 9. Believe me, the special products are easier than anything else. They may look weird, maybe, they may look difficult, but they are easier than anything else in factoring. So please hope for a special product at all times. Okay. Are we working on this? So what is it?
2a. Oh, it's a term.
It's a trinomial. Is it in descending order?
Yes.
Greatest common factor?
Yeah.
No, you cannot factor out 2 from 9. No greatest common factor. Negative leading coefficient? No. I hope for a special product. If it isn't, then I will have to move on to the other 2 methods. If it is a special product, if it is, what would you write?
I don't think we know what you're asking.
But 16 squared is not 16, right?
8.
Say it again.
8.
8 squared is not 16. Yes. 4a sine very good, everything squared. Okay, let's check again. First term squared. Minus 2 times the first times the second. How much is 2 times the first times the second? 2 times 3 is 6. And 6 times 4a. It doesn't matter, the order is not 24a plus the second term squared.
18.
The second term,
81.
the second term squared. Second
Greater
term
than
squared, 9. That's why this is so important. That's why this is so important. Let's do it again. First term plus the second term, everything squared, is the first term squared plus 2 times the first times the second plus the second term squared.
Can I see that next to the problem we just did?
Yeah.
Thank you.
Don't forget what you want to say, Whitney. Hold on 1 second. He doesn't believe me. Yeah, I have to do this. I'm kidding. I'm kidding. I'm kidding. I'm kidding. 4a squared, 16a squared, minus, because this is minus. I should have showed you this one. Minus 2 times 4a times 3. 2 times 3 is 6 times 4a is negative 24a, plus the second term squared is 9.
You're going way too fast, Brian.
But we've done this for a month already. That's why I said, please, I'm begging you. I'm begging you, write this problem, write this formula 10 million times, work on it with 10 million examples, so we have to make, because we have to make headway in chapter 6. So 4a squared, right? This is your 4a is right here.
Right.
4a squared is 16a squared.
Mm-hmm.
This is your 3. 3 squared is 9.
Okay.
And now the middle term. 2 times 4a times 3. 2 times 3 is 6. 6 times 4 is 24a. Because that's what the middle term is.
Okay. That's make sure I understand that.
So please remember this, because we cannot make headway. We will always come to a wall and hit ourselves. Okay, another one. 25. X squared minus 20x plus 4. What is it? So you understand why I need a month on this chapter?
Sure.
It's not easy. We need a lot of practice. Okay, what is it? Trinomial. Is it in descending order? Greatest common factor? No. Negative leading coefficient? When I say the next step is special product, I do not look at the middle term. If the first term and the last term are perfect squares, and this is not minus, if it's minus, there is no special product. And they will not be perfect squares anyway. Good. So is this a perfect square?
Yes.
What would you square to get this?
5a.
Good. Is this a perfect square?
Yes.
What would you square to get this?
2.
Good. So then in parentheses, you expect,
5x minus 2.
good. Do not trust it just yet. Okay. What is this middle term here? Okay. 2 times 5 is
10.
10 times 2 is? So this should be 20x. If it's not 20x, this is wrong. It is. You must check. So let me come up with this.
So you said the middle term has to be 20x, right?
Yes.
Does it have to be negative 20x?
I already established the sign. If this is minus, and I'm done.
Okay. then
I
the
will
sign
not
doesn't have to be-
re-discuss the sign again because I may make a mistake.
Alright.
So let me show you just to make sure. So that's why we talk about the sequence of signs and the sum and difference of cubes, so we don't have to go back and arrange or make a mistake, right? Same thing here. If this is positive, I'm done. If this is negative, done. I do not rediscuss it again and say, oh, but wait, but I'm multiplying 5 by negative 3x, and it's done. Okay? So if this is negative, done. Is that okay? Good. Perfect. So what is this?
It's a triangle.
Good. Is it in descending order?
Yes.
Negative leading coefficient. Greatest common factor. Special product. That's my next strategy. That's the next item in the strategy for trinomials. I cannot skip that. So when I'm asking myself that question, I forget about the middle term. I only look at the first and the last. Make sure they are special. Make sure they are perfect squares. And if they're not, then I have to move on to something else. So are they perfect squares? Good. And this is positive. Both are positive. What do you hope for? Exactly. I hope for 2x plus 1. However, don't get excited before we do what? Check the,
So it should be 4x.
yes, 2 times the first times the second. If this one is not 4x, I have to erase that. Is this 4x? No. We're going to look at it again in a minute. Okay? I cannot at this point say that this is not factorable because I have to check the other two. I'm sorry? Yes. Yes. I want to review. I'm going to come back to this one. I'm going to review the number 6 and then I will come back to this. So please don't let me forget. But this is not factorable using a special product. A special product is not applicable here. I have not said that this is not factorable. Okay? Good. So I would like to read, are we done with special products? Can I move on to 6? Item 6. Do we need more special products in trinomials? Yes? Chris? You want one more?
No, it's fine.
Okay, Ruby already answered. So we move on to the next strategy. I mean, the same strategy, trinomials, but the next item on the list. Yes? Okay. I'm trying to find, yes. X squared minus 3x minus 28. They are getting more and more complicated now. We're moving away from special products. Obviously, this is not a special product because 28 is not a perfect square, but what is important is that it's negative. Not a special product.
So what is this called?
It's strategy 6. No, I don't have a name for it. Okay, so what is it?
Trinomial.
Descending order?
Yeah.
Greatest common factor?
No.
Negative leading coefficient?
No.
Special product?
No.
No, because it's negative 28. That's why I said it's not a special product. Is 1 the leading coefficient? Good. So then I'm looking for two numbers whose product is and whose sum is.
This product is 3 the 28.
The sum is 3, the product is 28.
If you do not take the numbers with the sign in front, you will not be able to factor. Exactly. You cannot separate a number from the sign in front of it.
Oh, so negative 3 and negative 28?
Correct.
Okay.
This is crucial. Good. So we want to find two numbers whose product is negative 28 and whose sum is negative 3. Here's the thinking process, please. I start by looking at the product. Since the product is negative, how can I get a product that is negative from two numbers? Only if one is and one is.
Negative.
There is no other way. So I'm looking for a positive and a negative, such that the product is negative 28 and the sum is negative 3. Can anyone give us two numbers? If you find two numbers that fulfill both conditions, I cannot find another pair of numbers. There's only one pair. So, negative 7 and positive 4. Both conditions must be fulfilled. Is this? Is the product this? Correct.
Out of curiosity, what is the fastest way to find those two numbers?
Yeah.
Because I typically factor the the 3 and the 28 out. Like using a tree.
I would do it for
I can't
28.
help but think that's not the fastest way.
Depending on the number.
Right.
Depending on the number. This is the only way, basically.
Okay, so I am doing it the way.
Now, if the number is much bigger, then I would present it in prime factors, and I'll show you when we get to that.
Alright.
But for 28, there are not that many options. Very good question, actually. Since I'm looking for a negative and a positive, and their difference is -3, then they should not be too close to each other. If the difference, for example, is -1, they should be closer to one another.
Yeah, okay.
Like -6, -7, not in this case, of course. But if the difference is -20, then they should be one small and one big.
Right. Okay.
See what I mean?
Yeah, yeah.
So
That'll give me
if
a good starting
the
point.
sum is -3, they should be balanced.
Okay.
If the sum is -20, one should be very small and one should be very big.
Right. Okay.
Quote unquote. Okay. So then what is the factor form?
X minus 7, X plus 4.
That's it. Let's check. X times X squared, check. Positive 4X, -7X, check. -7 times 4, check. Next one. X squared minus 7X plus 10. However, that's just me. We're all different, right? Just me. I would have preferred a special product. I don't want to do all this. Special product, you check the first term and the last term. I put the special product, check the middle term, I'm done. Here I have this thing. I have to say, okay, then the product is negative. I'm looking for a positive and a negative, and then the sum is -3, and then blah, blah, blah. But again, that's me. The special product is much, much faster and easier. Good. So x squared minus 7x plus 10. Now at some point in time, you're not going to need to do this for coefficient 1. You probably don't need to do it now. Product is how much? 10. Sum is?
Wait, we're not going to go through all the steps?
Okay. Well, yes, I'm sorry. Okay, what is it?
Trinomial.
Is it descending order?
Yes.
Greatest common factor?
No.
Special product.
Yeah, I would say no.
No, because 10 is not a perfect square.
Wait, so I know this is going to be a dumb question, but how do you know 10 is not a perfect square?
Because there is nothing I can square to get 10.
Oh,
1 squared, 2 squared, 3 squared is 9, 4 squared is 16.
I got you.
10 is not a perfect square, so we cannot fit
I guess I always confuse with something being divisible by 2 division.
Oh, okay. Perfect
It's not-
square
it's not
means,
the same.
yeah, 9 is a perfect square of 3.
Right.
16 is a perfect square of 4. You
Right.
see, if you don't ask these questions, I will not have a perfect presentation.
Right. Okay.
Perfect is hard. So, good. So, 10, there is no number that I can square to get 10.
Okay.
That is an integer.
Right.
Because there is a number that I can square to get 10. It's the square root of 10.
Right.
But the square root of 10 is not an integer.
Right.
So we don't really use anything else but integers when we factor. Okay, good. So then, not a special product.
Right.
Is 1 the leading coefficient?
It is.
So then I'm looking for two numbers whose product is
Yeah, 10.
And whose sum is? Not, you cannot separate the number from the sign in front of it. So I start by looking at the product. Since the product is positive, I am definitely looking for a negative
2 positive numbers,
or
2 negative numbers.
correct. Now I'm looking at their sum. And I know what type of numbers I'm looking for. Exactly. Do we understand why we're looking for two negatives?
No.
Okay. The product is positive. So I have only two options. Both positive or both negative to get a positive product, right?
Yeah.
Both positive or both negative. If they're both negative, I get a positive product, correct?
Yes.
Okay, now, in order to establish which one, I look at the sum. I'm telling you the sum of these numbers is negative. What can they be? Both positive or both negative?
Negative.
Because the sum of two negative numbers is negative. The sum of two positive numbers is not negative. So I'm looking for two negatives.
-2 and -5.
Right. So then the product, the factored form is?
Yeah. Yeah, I think this is the easiest thing to know.
Okay. That's what I said. Just me. I said that. Just me. It's much easier for me to apply a special product. I just look at the product, the perfect squares, write the form, check the middle term, I'm done. I don't have to think and separate and think about signs too much. But as I said, we're all different. Good. Next example. Now, can you do 2 for me on your own? I want to see x squared plus 6x minus 16 factored. And I want to see x squared plus 11x plus 24 factored. And also x squared plus 14x minus 32. Please go through the entire strategy because it makes your life easier. It's not 1024, is it?
Also, another question too. What's the easiest way to figure out if something is actually a perfect square?
You can take the square root from it
What do you mean by that?
with the calculator. So we haven't discussed that because that's in chapter 10. Chapter 10 is part of book 12.
Okay.
So let me show you with the graphing calculator. It's a very good question. So second, and this symbol right here, square root. So if I put 10 and I press enter, I'll get an irrational number. But if I put second and 25, square root of 25, I would get 5. Because 25 is a perfect square.
Okay.
So the square root, I don't think you have that in, maybe in a math or something.
Yeah, I'm trying to see if I got one.
So this is how you find to determine.
It's just a little confusing to me sometimes because
Yes.
they don't clearly state what you should be using a calculator for and what you should be doing in your head. I noticed everyone else in the class is like, oh yeah, that's a you know.
They may
perfect square.
know.
And I'm like,
Yeah,
how do you know that?
Yes,
Like,
they may know it. Okay, I understand.
So.
Do we have a factor form for the first one? First of all, it's a trinomial, descending order. Yes, greatest common factor. No, negative leading coefficient. No. Special product. Personally, I always hope for a special product. It's not a special product because it's negative 16. So then what is the factor form?
The difficult part for me is looking for the numbers that sum up to both of them.
So two conditions have to be fulfilled here. The product has to be,
16, negative 16,
thank you, and the sum must be
positive 6.
correct. So we start by thinking of the product first. Okay. The product is negative, so I'm looking for a positive and a negative. Okay. Now the sum is 6, so they have to be 6 away from each other, because one is positive and one is negative. So now I think, okay, what numbers, if I multiply them, I get 16. 1 times 16, 2 times 8, 4 times 4. There is nothing else. Which of these three will work? 8 and 2.
Wait, is it 16 or negative 16?
No, but when I think of the factors, you're right, it's negative 16. But when I think of the factors, the options are 1 times 16 or 16 times 1.
Well, I like to think of it as multiplying 8 by negative 2 because that makes it easier for me to figure out
Right,
the sum.
but
Because I
Ruby-
say 8 minus 2 is
Right.
6.
Right, but Ruby was asking me something else. I was trying to answer her question.
Oh,
So first I'm thinking of 16. 1 times 16, 2 times 8, 4 times 4. Which of these will give me a difference of 6 when I subtract them? So it's 8 and negative 2. Is that better?
Yeah.
So 8 and negative 2. So then what is the factor form? Okay, let's look at the next one. Is this okay, everyone? Chris?
Mhm.
Okay. X squared plus 11x plus 24. What is it? Yes.
how are you
Wonderful.
looking for the answer?
Yeah, so it's in descending order, greatest common factor, no negative leading coefficient, no special product, I hope, no. 24 is not a perfect square. So then I'm looking for two numbers whose product is,
Yeah.
and whose sum is. Since everything is positive, I'm looking for two positive numbers. And they are? Do we all agree? Yes? Okay. X squared plus 14x minus 32. Descending order, it's a trinomial, descending order, greatest common factor, no, negative leading coefficient, no, special product, I hope, no. 1 is a leading coefficient, so then I'm looking for two numbers whose product is,
Negative 32.
correct,
14.
and the sum is 14. I always start with the product. Since the product is negative, I know exactly what I'm looking for. What type of numbers? Positive and negative. So can anyone give us two numbers or find for us two numbers whose product is negative 32 and whose sum is 14? Because one is positive and one is negative. One has to be small and one has to be big.
16 and negative 2.
Right. Do we all agree with that? Because their sum, since they are opposites, and their sum is 14, one must be high and one must be low. So can anyone give us the factored form?
X plus 16, x minus 2.
Do we all agree? Everyone? Okay. Trinomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, I hope, no. I shouldn't have said that. Special product, I don't know. Because they are perfect squares. So this is a perfect square, this is a perfect square, what do you hope for? I cannot
X
say
minus.
plus, because, yes. I hope for x minus 2 squared. X minus 2 squared. What is the middle term of this expansion that I know from chapter 5? Negative 4x, correct. If this is not negative 4x, this is incorrect. That's not the factored form. They're not the same. So then now, I'm trying to find two numbers whose product is and whose sum is good. Since the product is positive, I know both numbers have to have the same sign. And their sum is -2. What sign do they have to have? Negative. We agree? They both have to be negative?
Yeah.
Good. So can we find two numbers whose product is +4? And remember, +4 is only 2 times 2 and 4 times 1. There is nothing else. So -2 minus 2, is that -2? -1 minus 4, is that -2? What do you conclude about this?
It's not factorable.
Good. Moving on. Correct? Yes? And what was the problem that I promised to go back to? Okay, I got it. 4x squared plus 5x plus 1. We only established, and we're not going to establish it again, that this is not a perfect square. So trinomial descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, no. We already checked. 1 is the leading coefficient.
No.
No, so that's the last chance. Step 7. Good. In step 7, and the last one, I am trying to find two numbers whose product is, and now I have to incorporate this in the product. I didn't have to do it before because it was 1. But now it's no longer 1, and I have to incorporate it in the product only. The sum does not change from before. What is the sum? Exactly. So now, I always start with the product because the product gives me a lot of information. The product is positive. If the product is positive, both numbers have to have the same sign. Do we agree or disagree? Good. But now I look at the sum, and the sum indicates to me that both numbers must be positive. So I'm looking for two positive numbers whose sum is 5 and whose product is 4. 1 and 4. There is nothing else. At this step, I cannot write the answer. Do not get into that trap. When the leading coefficient is not 1, you have so much more work to do. You cannot write the answer yet. And the work involves replacing this term by, please dictate, x plus
4.
x plus x plus 4x plus 1. I use the numbers you gave me to break 5x into two terms. I use the 1 and I use the 4 that you gave me. And I replaced 5x by this sum, which is the same thing. The next step is I have to factor by grouping. Now factor by grouping. Disregard for a moment this last two terms and look at these two and tell me what to factor out.
X.
Just x. There is nothing else that is common to those two terms. X. What is left in parentheses?
4x.
I start with two terms. If I don't write two terms, I'll never recover them. X times 4x. X times 1. Agreed?
Yeah.
What should I have? And now I'm coming back to Ruby's question. It was awesome because she really helped me with that question. This was her question. She said, what do I do this? Here, do this. And this is exactly what I'm doing now with where we are. That's the step. Good. So then, what should I have in parentheses in here so I can continue? I refuse to look.
So it's That's fine.
Now I look, because I know I'm not going to make a mistake. Remember, I need two things in here. I need a symbol and a factor. If you forget the symbol, you're not going to factor. So, what times 4x is 4x, and what times 1 is 1. I need sign and factor that I pull out. Exactly. Since we don't really write 1, I'm just going to put it dotted. Now, sort of, I have two terms. This product and this product. They have a common factor that I have to pull out.
4x plus 1.
Right. Don't erase it like this, but these are gone.
And then
What?
X plus 1.
Say it again.
X plus 1.
Correct. Let's take a moment and check because I don't trust this. No problem. 4x times x, 4x squared. 4x times 1, 4x plus another x is 5x. 1 times 1 is 1.
I do have one question.
Please.
And I have a feeling I know how you're going